Continue our leetcode 75 series where we have solved 40 questions out of 75, and now we have to move forward. So we have solved array string questions, two pointer, sliding window, prefix sum, hash map and set, stack, queue, linked list, binary tree DFS, binary tree BFS, and now we have to solve binary search tree. Okay, so the first question of binary search tree is search in binary search tree. So what is the main difference between the binary tree and binary search tree? So in a binary search tree, let's tell you, in a binary search tree, let's suppose there is 4, 2, 7, 1 and 3. Okay, so in a BST, you can see the pattern that in a left side there is a smaller element than a root. Okay, so you can see that here is a 4 and the smaller element lies in left side and the greater element lie in right side. Okay, so the 7 is greater than 4, so the 7 is on a right side, and 2 is smaller than, so it is on a left side. Okay, in the same way you have to compare with the root, only root. So for this is the root, so the root is 2 and the smaller will lie on a left side and a greater will lie on a right side. Okay, so the 3 is greater than 2, it will lie on a right side, and 1 lie on a left side. Okay, but in a binary tree there is no such pattern as follow. You can draw anything but having a two children only. Okay, so these are the basically two difference between the binary search tree and a binary tree. Okay, so what this question is telling, there is given a root and a value. Okay, there is given a root of a binary search tree and an integer value. So you just have to search the element in a binary search tree, and okay, you just have to return for there is given a root of a binary search tree and a value 2. Okay, so you just have to find the value 2, that it is present or not. If it is present, then you just have to return the 213, 213, and if it is not present, then you just have to return the value, I mean null. So here is given a example, 4, 4, 2, 4, 2, 7, 1 and 3. Okay, so here is a example. So you just have to find the value 2. So here is a value 2 that we have find, and you just have to return the subtree also. You just have to return the 213, 213, the subtree. Okay, so you just have to return it. And if somewhat the value is 5, there is no such value, so you just have to return the null, nothing. Okay, so these are basically two different things. So first you have to check that if you just have to check if root is equals to null. If it is null, then you just have to return the null. Okay, if the root is null, means there is no such binary search tree, then you just have to return return null. Okay, and then you just have to check if root ka val is equals to value that we have to find, then you just have to return the root. Okay, if suppose there is a 2 and you just have to find a 2 also. Okay, so means the value and the root value is same, so you just have to return root. Okay, you just have to return root. And if it is not, then you just have to, else if, you just have to move, you just have to check root if root val is greater than val. Okay, then you just have to pass the function search root ka left comma val. Okay, you just have to do two things, else return, you just have to return root ka right comma val. You just have to pass the function. Okay, so let's do this. Let's write this function. First you have to check, you just have to check if root is equals to null. If it is null, then you just have to return null. Okay, and again you just have to check if root val is equals to value that we have to find. Okay, then we just have to return the root. Else if root ka val is greater than val, then you just have to return search in BST. Then you just have to pass the function search in BST with root ka left comma val, else return root ka right comma val. So let's run this code. Yeah, this code works fine. Let's submit this. Yeah, this has been accepted. Thanks for watching.